Today we are going to see a PN junction diode under reverse bias. Reverse biasing means that the P side of the semiconductor diode will be connected to low potential and the N side of the semiconductor diode is connected to high potential. So we will reverse the battery. So in the previous class you have seen forward biasing. Forward biasing we have connected P side to high potential, N side to low potential. Here we will connect P side to low potential and N side to high potential. Now you can see the diagram here. This is the diagram of a PN junction diode without having any biasing. It is not connected to any power supply. Okay, and this region is called depletion region. This is the barrier potential acting in this direction from positive to negative. This is the width of the depletion region. We can mark it as W1. W1 is the width of the depletion region. The depletion region do not contain any either electrons or holes. They contain only positive ions and negative ions. Okay, the ions corresponding to acceptor or the donor we can represent in the depletion region. This region do not contain any they are not containing any mobile charge carriers, movable charge carriers. Okay. Now in the N side region, in addition to the electrons, what will be present? Minority carriers will be present. I will draw a few holes. Here I will draw a few electrons. These are the minority carriers. Okay. Now here also I will draw a few electrons here in the P side, few holes in the N side. Now this is for a reverse biasing. Here we can see the negative of the battery is connected to P side and positive of the battery is connected to N side. So the negative potential here will attract the holes towards this end and the positive potential attract all the electrons to this end. Okay, so they will experience a pulling towards the battery. So electrons will be pulled towards the battery, holes also will be pulled towards the battery. And now what will happen? Many holes will be moving towards the battery. Many electrons also will be moving towards the battery. So these regions will be containing only ions, that is acceptor or donor ions. Now what happens? The width of depletion region goes on decreasing. From the depletion region, more electrons will be pulled away from the junction, more holes will be pulled away from the junction. So what happens is many ions will be exposed. Positive ions will be exposed on the N side and negative ions will be exposed on the P side. Now in short, what we can understand is what happens is the width of depletion region increases. Now during reverse biasing, this is the main thing happening, that is the width of depletion region increases. It increases the width of depletion region. If W1 is the width of depletion region without any bias, W2 depletion region with a reverse bias, how can we compare? W1 will be less than W2. So W2 will be large. Now in terms of potential barrier, we can express, we can draw the diagram like this. This is a lower potential and higher potential represented by this. This is situation number 1 without any bias. This is the potential barrier. Now what we are connecting? We are connecting external battery. What's the direction of the potential difference of external battery? Negative, positive. So this is the direction. So I can draw a direction of the external voltage like this. This is the direction of external voltage. I will draw like this. Okay, this is the direction of V. That is negative here, positive here. This is the direction of V. Now what about the barrier potential? Barrier potential also in the same direction. Barrier potential in the same direction as the external potential. What about the net potential difference? It will increase. V0 plus V will be the net potential. So what happens? The barrier potential goes on increasing. Now in the second situation, when we reverse bias, this will be the potential difference. It is beyond V0. It increases above V0. So barrier potential increases. No electrons are no electrons are able to cross a junction. No holes are able to cross a junction. So minority carrier injection is not possible. So forward current is not possible during reverse bias. Now what can happen is, means the electrons are not able to come to the junction, holes are also not able to come to the junction, but there are minority carriers. You can see a few holes here, a few electrons here. These electrons will be repelled by the negative potential. These holes will be repelled by the positive potential. If the potential value is very large, what happens is This holes will experience a pushing in this direction. Electrons will be pushed in this direction. They can move across the junction. This will produce a slight current in the order of microamperes. And this current is called a reverse current. Okay, so reverse current. Reverse current will be in the order of microamperes, like 1 micro, 2 micro, like that. It will be only in the order of microamperes. If we further increase the voltage of the reverse bias, like 20, 30, 40 continuously increase, what happens at a particular voltage, the junction breaks down. The junction breaks down and current rapidly increases. That's called a breakdown, and the corresponding voltage is called breakdown voltage. We need to apply a voltage, very large value, it will be VBR. VBR is called breakdown voltage. Then the junction breaks down, the temperature increases at the junction. Then afterwards that diode will not be useful. So in practical circuits, we cannot use the diode beyond the breakdown voltage. Okay, that's called a junction breakdown. So these are the things taking place during a reverse bias. So during reverse bias, there is no current conduction, there is no forward current. Or we can say it act as an insulator. The diode will behave as an insulator. So in the previous case, in forward bias, we have seen that the diode was behaving like a conductor. Now the diode is acting as an insulator during reverse bias. Okay, means it will not allow the current to flow from negative side to positive. Electrons are not able to move. Means current is not possible from positive to negative. In this direction, there is no current possible. But there will be minority current possible, that is called reverse current. And the reverse current is almost independent of the applied voltage. It will be almost the same, almost steady. But if you increase the voltage further beyond VBR, breakdown voltage, there is a safe value called the breakdown voltage. If you increase beyond that value, what happens is the junction breaks down and current rapidly increases. Okay, that can destroy the diode. Further, the diode is not able to work. Okay, so that's about the PN junction diode under reverse bias. So in reverse bias, what happens? The external potential will be in same direction as that of the barrier. This is the direction of barrier potential. This is external potential. Both will be in same direction. They will get added up. So electrons are not able to cross the junction from N side to P side. Holes cannot move from P side to N side. But there will be a minority current in the order of microamperes. So we can say there will be minority current. Minority current is possible. Minority current, or it is called a reverse current. So reverse current is possible during reverse bias due to the minority carriers, and it will be in the order of microamperes. Okay, this is called for PN junction diode under reverse bias. So okay, hope that you have understood. Thank you.